Differentiability of a continuous function is a very important concept. Let us understand it in more details. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a very important question based on Calculus Unit 1. The playlist has more than 100 questions for you to practice. Question here is provide examples of the functions that are continuous but not differentiable in their domain. It is extremely important and it helps you to understand the basic concepts. Now, two things. One, the function is continuous. That means at every point, actually, you can find the derivative. But says not differentiable in the domain means there are a few points within the domain of the function where it is not differentiable. So the function will not be differential and continuous. Those could be three conditions, right? So there are three conditions when this can occur. One is when you have a cusp or you have a corner or you have a vertical asymptote. So these are the three conditions when a function could be continuous but not differentiable. So if I sketch the graph of each one of them, it will be absolutely clear to you. So let me do that. So I'll just sketch three functions here. Cusp. Cusp is a graph which is kind of like this. Do you understand? So as you can see, it is a continuous function. However, at the origin O, if you want to find the derivative of this function, it is infinitely large. It is not a real number. So, for example, the function could be y equals to x to the power of, let's say, 2 over 3. Now, this particular function, if you find the derivative of this function, it will be what? 2 over 3 times x to the power of 2 over 3 minus 1, right? Which will give you minus 1 over 3. So as you can see that at x equals to 0, you can see that y prime or the derivative is infinitely large. And so clearly it is not differentiable at origin, right? Now let's take up another example which is based on corner. A common function is absolute value of x. So if you have y equals to absolute value of x, you know it is continuous, however, it is not differentiable at 0. So because at 0, you can see you can have many tangent lines, right? All these lines could be tangent at 0. We are not very sure which one is the correct one, right? If you see, the derivative from the left side is negative 1 and from the right side is positive 1. It is not the same. So that is also is not differentiable. Perfect. So if you see y equals to absolute value of x, it is a continuous function, but y prime at x equals to 0 does not exist. Make sense? The third function is where you have a vertical asymptote. The graph of the function could be something like this. You see that vertical asymptote at the origin? Now, in all the three examples, I have taken functions, basic functions, which where we are considering differentiability at the origin itself. While these could be translated left or right, and so you could have any other point also. Perfect. So this is a function which looks like y equals to cube root of x, right? Let me write y equals to cube root of x. Now, if you find the derivative, which is y prime, will be 1/3 of x to the power of 1 over 3 minus 1, which is minus 2 over 3. So clearly, here what you notice is that at x equals to 0, y prime does not exist. So that becomes our third example. However, as you can see, the three conditions where the functions are continuous but not differentiable are when you have a cusp, or when you have a corner, or we have a situation with a vertical asymptote, as given in the last example. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.